Hi, my name is Caleb Porter, Francisco.
Here we have our simple data latching, which is a D latch, and this circuit is used to model the way computers store memory. For this experiment here, if the button is pressed, then it will take on whatever those values are. Now note that these values are in radix complement, so they're signed, or at least have the potential to be signed. As we can see, we initialized this to 0, so I mean nothing's going to happen. So I switch this to 1, nothing happens. If I switch any of these guys, nothing will happen since I'm not pressing the button, because the button here acts as our toggle switch. So let's say this is 1, at least it should be 1, it's only one value. Then it'll store it,
and it'll hold this one value until you press the button again with a different combination of switches.
And I mean, if I just happen to have the same value, then nothing's going to change to the same value. But it'll store that number in the circuit because of the state of the current circuit. And let's say, since these are radix complement numbers, and we have something easy that we can expect. Let's say this should be a -1 value. So let's do that, and as you can see, it's a -1, and again, doesn't matter what we do here, it'll stay the same until we press this button. So now we just mess around. This is what, 8, 8, that was 8, and you can see it's still 8, negative what?
128. It's just the switch.
Oh, that's true. And they're at -128.
And we can go back and forth between positive and negative numbers, such as 1 and -1. So if we have all the switches down except this one, it's the right switch, it's 1. And then if we have all the switches up, it'll stay +1 until.
So we have it down. It's -2, 4. Sorry about that. -3.
And then if you put all the switches up,
5.
It should be, or all of them down except for this left one, it's -128. When you put the right one up, -127. So it goes back up from -128 to 0.
125. And so this is our simple
data latching
D latching circuit. And yeah, there it is.